Welcome back to the workshop. Today, we're taking on a precision machining project featuring a bevel pinion gear and shaft assembly. In this video, you'll see how a universal dividing head is used on a milling machine to cut accurately spaced gear teeth with exceptional precision. We'll cover the complete setup, including mounting the workpiece, aligning the dividing head, selecting the correct gear cutter, performing indexing calculations, and machining each tooth step by step. If you enjoy heavy-duty machining, gear manufacturing, and professional workshop techniques, you're in the right place. Let's get started and see how precision engineering transforms a raw gear blank into a high-quality bevel pinion gear and shaft assembly. High-speed steel gear cutters are commonly used for general machining because they provide excellent toughness and can be resharpened multiple times. For high-production environments or hardened materials, carbide gear cutters offer superior wear resistance and longer service life. Regardless of cutter type, the cutting edges must be sharp and free from damage before machining begins. The cutter is carefully mounted on the milling machine arbor. Spacers and arbor supports are installed to minimize deflection during cutting. The arbor nut is tightened securely while ensuring the cutter rotates freely without wobble. Cutter runout is checked using a dial indicator to verify accurate installation. After mounting the cutter, its center line is aligned precisely with the center line of the bevel pinion gear blank. This alignment ensures symmetrical tooth formation on both sides of each gear tooth. The milling machine table is adjusted in the X, Y, and Z directions until the cutter reaches the exact cutting position specified by the gear drawing. The cutting depth is determined using engineering calculations or machine setup charts. Trial cuts may be performed on a sample piece to verify dimensions before machining the actual gear blank. Precision measuring tools such as vernier calipers, micrometers, and depth gauges are used to confirm setup accuracy. The next stage involves indexing calculations. The dividing head enables the operator to rotate the workpiece by an exact amount after each tooth is cut. Most universal dividing heads have a worm gear ratio of 40:1. Meaning 40 complete turns of the crank rotate the spindle 1 full revolution. A universal dividing head mounted on a milling machine is a precision tool used to rotate a workpiece to exact angles during machining operations. It is commonly used for cutting gear teeth, splines, slots, hexagons, and other evenly spaced features that require high accuracy. The large perforated disc attached to the dividing head is called the index plate. It contains multiple circles of accurately spaced holes that allow the operator to control the spindle's rotation using a crank handle and adjustable sector arms. By selecting the correct hole circle and turning the crank by a calculated number of holes, the workpiece can be indexed with exceptional precision. In the setup shown, the dividing head spindle is positioned horizontally, indicating a simple indexing operation. This arrangement is ideal for machining equally spaced features around the circumference of a workpiece. Universal dividing heads can also be connected to the milling machine table feed through a gear train for helical milling, making them one of the most versatile accessories in precision machining and gear manufacturing. Once mounted, the machinist checks runout using a dial indicator. The indicator is positioned against the shaft or gear blank while the spindle is slowly rotated. Any excessive runout is corrected by repositioning the workpiece until the reading falls within the specified tolerance. Precision gear manufacturing demands extremely low runout to ensure every tooth is machined uniformly. After confirming alignment, the tailstock pressure is adjusted. Too much pressure may distort the shaft or overload the centers, while too little pressure can allow the workpiece to shift during machining. Proper support ensures stability throughout the milling process while allowing smooth rotation during indexing. Attention then shifts to the milling machine setup. The machine table is cleaned thoroughly before mounting the dividing head and tailstock. The dividing head is securely bolted to the table using T-bolts and clamps. Every mounting bolt is tightened evenly to eliminate movement under cutting forces. The dividing head spindle is positioned at the required angle based on the bevel gear design. Unlike spur gears, bevel gears require angular positioning because their teeth are cut on a conical surface. The spindle angle is adjusted according to engineering drawings or manufacturer specifications. Precision angle scales and locking mechanisms ensure the correct position is maintained throughout machining. The milling cutter selection is one of the most critical stages of the setup. The cutter must match the module or diametral pitch of the gear, the pressure angle, and the number of teeth being produced. Gear cutters are manufactured in numbered sets, with each cutter designed for a specific tooth range. Selecting the wrong cutter produces an incorrect tooth profile, leading to excessive wear, noise, and poor gear engagement. Before any cutting begins, the success of machining a bevel pinion gear and shaft assembly depends on careful preparation, accurate setup, and precise indexing. Every step performed before the milling cutter touches the workpiece directly affects the quality, accuracy, and service life of the finished gear. In professional workshops, experienced machinists spend considerable time checking alignment, selecting the correct cutter, and calculating the indexing because even a small setup error can result in incorrect tooth spacing or poor gear performance. The first step is cleaning the bevel pinion gear blank, shaft, and all mounting surfaces. Dirt, rust, burrs, or metal chips are removed to ensure the workpiece sits perfectly against the mounting surfaces. Any contamination between the workpiece and the mounting fixture can introduce runout, leading to uneven tooth depth and inaccurate gear geometry. The shaft journals are inspected for damage, and all contact surfaces are lightly oiled to prevent corrosion while allowing secure clamping. Next, the dividing head mounted on the milling machine is thoroughly inspected. The spindle is rotated by hand to confirm smooth movement without excessive play. The tailstock is aligned with the dividing head center, ensuring both centers share the same axis. That brings us to the end of today's workshop project. We successfully completed the setup and machining process for the bevel pinion gear and shaft assembly using a universal dividing head on the milling machine. Every step, from accurate mounting and precise indexing to careful gear cutting, plays a vital role in producing a high-quality gear that delivers smooth power transmission and long service life. Precision, patience, and proper machine setup are the keys to professional gear manufacturing. Thank you for watching.